Okay, so that last recording went a little bit long, and I'm actually going to break the rule that I just said. I'm going to take the derivative, but when I do this natural log, I'm going to apply a log rule first. So I am going to change this into natural log of y minus natural log of x plus 2 to the y equals 1. And then we're going to take the derivative with respect to x of both sides. And remember, d dx of 1 is just 0. Okay, this is my derivative of a natural log with the chain rule, so it has to be y prime over y. So dy dx over y. Derivative of regular natural log is just 1 over x. Derivative of natural log of y is natural log of 2 times 2 to the y times dy dx. So that one requires a chain rule because I'm taking the derivative with respect to x, and this is not just an x, it's a y. Okay, we want to collect all the dy dx's on one side and all of the not dy dx's on the other side. So that just means I move a 1 over x on this side. On the left, I have dy dx 1 over y plus 2 to the y times the natural log of 2. Let's go ahead and build this one up to have a y over y so that I have dy dx. So 1 plus natural log of 2 y 2 to the y all over y equals 1 over x. So now in order to divide, I really just need to cross multiply. So it's going to be y over x times 1 plus the natural log of 2 times y times 2 to the y. And now I need to actually evaluate this at the given point, which was at e comma 1. So we're putting 1 in for the y, e in for the x's. So I have natural log of 2 times 1 times 2 to the first. And this is kind of a nasty number, but if you evaluate in your calculator, it comes out to about 0.15. Looking at the graph, I mean, at least it's positive. That seems reasonable. This also seems like it's not a very steep slope, so 0.15 doesn't seem too crazy. So now I'm going to show you how to check your implicit derivatives. So if you just go to Wolfram Alpha and you start typing implicit, implicit differentiation pops up. We type in the function whose derivative, not function, it's a implicit relationship, whose derivative we want to find. It was plus 2 to the y. There's my exponent, there it is, equals 1. And differentiation with respect to x, hit compute. Okay, and if we look, that looks like pretty much the same thing I have, except they took a negative out here. So let's zoom back out on mine. So we're a little bit off. And I am not seeing y. Nope, I see it now. I typed it in wrong. It's log of y over x, and so I had my subtraction order backwards. So let's try that again. Okay, there it is with the proper form, with the y in the numerator, and you can see that this actually exactly, other than the order of our addition and our terms in the bottom, this exactly matches what we have. So you can always check this for anything. It's not going to show you step by step. There is a step-by-step solution, but you have to pay for that, but it will at least allow you to check your answer.